a simple situation like this. And you want to find that area. Well, then you say to yourself, well, find that area under that curve. And then find the area under that curve. And subtract. This is what I call the Math 99 way of finding areas. Or the SAT way of finding. On the SAT, they certify you with these kind of problems. And then see what's that area there. Oh, basically, the square and subtract the areas of the circles. So same thing here. You take the area under the top one, take the area under the bottom one, and subtract. That is to say that this would be, let's say this was A, and this was B. Okay, the area from A to B of f of x, the area from A to B of g of x, and subtract. And then of course you know something about integrals. So, integral of f minus integral of g is the integral of f minus g. That's one rule you can't use. For integration or chain rule, but that's not something a rule you can use. And you are looking for area here. You better make sure that f is bigger than g. Otherwise, you are going to get negative count. So, if you have two functions and you are trying to find the area between them, you want to keep your head straight. You want to make sure that, as you say, you will have to break this up into two integrals. That is to say, integrate that thing, find the area under that, minus the area under that, then find the area under that, subtract the area under that. But the problem, Mr. Tyler, is where is this taking place? What is this? What is this? What is this? Where are the knots? K-N-O-T-S. And somebody will say, find the area between these two curves. That's it. Find the area between these two curves. I will make a picture. What is this knot? What is this knot? So the first step in this procedure is to find the knots. How do you find the knots? You have to solve an equation. You have to solve an equation. And you are all experts at solving equations. That's why you took pre-calculus. You have to. Now what I'm going to write may seem like it's a joke, but it's actually very hard. What values of x? For what values of x is f of x equal to g of x? Now you have to solve for x. Well, you know, solving equations is a nasty business. Well, that is the first thing. You have to find the knots, solve the equation. In other words, you may have to do something like this: 1 minus x squared equals x cubed. How do you solve that, Mr. Harris? You're going to ask your pre-calculus friend. Your pre-calculus friend will say, well, rational zero theorem, and you try the zeros, and you try this synthetic division, you check that zero, no, the remainder is not a factor, not a whatever. All right. And you have to factor it. Well, I should pick out those ones. They're experts at those things. And so the zeros are x equals 1. This is around 10. X equals 1, x equals negative 2, x equals 3. The not would be x equals 3. Negative 1, sorry, negative 2, 1, and 3. Well, that is the first thing you have to check. You have to find the knots. Not an easy task. Now, the best way to find knots is how, Miss Yasmina? Use the beast. Okay? Crack the two things and see where they intersect. And then say, hey, by the way, I do know how to factor it. Yes. Who had pre-calculus with you? Only Miss Yasmina. Let me show you a trick. Anybody know how to factor this? Yes, your math 99 friends are terrified when you say, well, you put two numbers and multiply to negative 1 and add up to 0. Or you say, difference of squares, a squared minus b squared, a plus b times a minus b, and all that nonsense. You know what factoring is, right? Man, why don't I have my own calculator? Well, anybody know why I don't have my own calculator? Yeah, I've lost about 3 of these at GDC. Lost an iPad at GDC. Well, I don't remember. Let me show you how to factor. Miss Yasmina knows how to factor. I think she had a good calculator. So I'm going to graph x squared minus 1. And what are the zeros?
Negative 1.
Minus 1, when x is 1, y is 0. And when x is negative. That is the quick way to factor. Alright, what will make the function 0? X is 1. Okay, now, Mr. Tyler, after you do this, then you have to do the absolute value on each interval. How do you find the absolute value? We'll see which one's on top of which one. How do you find out which one's on top of which one? Use the beast. Huh? Use your calculator. Say, hey, looks like on this interval, this one's on top of this one. No problem. You pay $150 for that one. So I'm going to assume we're looking at one interval. Just on one interval. And then, of course, you will do this procedure on every interval. All right? So assume on the interval a to b, f of x is bigger than or equal to. So then you want this area here. Do that for x and g of x. Okay. So this area here is exactly the area under f minus the area under g. The area under f minus the area under g. So say, since f is, you can subtract, the difference of the integrals is the integral difference. Provided f is bigger than g, otherwise you're going to get negative. Now you'll have to do this on every interval. So you'll say to yourself, well, here is it. So you'll integrate f minus g or g minus f on each interval, depending on which one's bigger. So if on this interval f is bigger than g, then you do f minus g. If on this interval g is bigger than f, then you do g minus f. Ms. Yasmin, I think we also did this in calculus 1. No? Okay, let's do an example. I want to find the area enclosed by these two curves. 2x minus x squared and 2x